Hello and welcome. In this video, we will learn what is normalization, what are the different forms of normalization, and how to remove redundancy in normal forms. At the end of this video, you will be able to describe the different types of normal forms and differentiate between third normal form and Boyce-Codd normal form. Why do we need to normalize database? What happens if the database is not normalized? Let me answer these questions for you. It becomes difficult to handle and update the database without facing data loss. Also, without normalization, database systems can be inaccurate, slow, and inefficient, and they might not produce the data you expect. Now let us see what normalization is. Normalization is a method of organizing the data in a database. Normalization is mainly used for two reasons. One is to avoid the duplicate entries in a database. Another is to make relations free from insertion, deletion, and update anomalies. Normalization follows a set of rules in order to avoid such problems and to bring the database to a consistent state. These set of rules are called normal forms. Database normalization is divided into 6 normal forms. First normal form, second normal form, third normal form, Boyce-Codd normal form, fourth normal form, and fifth normal form. Let us look at each one of them. A relation is said to be in first normal form only if all the attributes in the relation contain only atomic values. Let us take an example of a student database. As you can see in the table, the student Adam has 2 subjects, biology and maths, and both are stored in the same field. This shows that the student table is not in first normal form because subject column for Adam contains 2 values. However, the rule of first normal form says that each attribute of a table must have a single value. To bring the student table to first normal form, we have to place biology and maths into 2 separate rows. Hence, we can say that the student table is in first normal form. Now, let us look into second normal form. A relation is said to be in second normal form if it is in first normal form and every non-key attribute must be fully functionally dependent on the primary key. Let us take the same student table, which is already in the first normal form. In this table, the student column and subject column are comprised to form concatenated primary keys. However, the table is not in second normal form because there is a partial dependency of primary key and column. A non-key attribute age is dependent on the student column, but it is not dependent on the subject column. This shows partial dependency of age column on primary key. In order to make this table comply with second normal form, we need to split the student table into 2 tables: student age table and student subject table. Now, if you look at the student age table, the column age is fully dependent on the primary key student. And if you look at the student subject table, the column subject is fully dependent on the primary key student. Hence, we can say that these 2 tables are in second normal form. Now, let's look at third normal form. A relation is said to be in third normal form only if it is in second normal form and every non-key attribute is non-transitively dependent on the primary key. If any relation has transitive dependency on the primary key, then the relation violates the rule of third normal form. Let us consider an example of student detail table which is in second normal form. Here, the column course ID is dependent on student ID, whereas course name is dependent on course ID, but not on the primary key student ID. This dependency is called transitive dependency. Now, let's bring the student detail table to third normal form. All we need to do is to split the table into 2 separate tables: new student detail, and student course table as shown on screen. Now, if you see the student course table, the column course name is dependent on the primary key course ID. Hence, we can say that the relation is in the third normal form. The next type of normal form is Boyce-Codd normal form, or Bcnf. Bcnf is an advanced version of the third normal form. It deals with certain types of anomaly that is not handled by the third normal form. The table is said to be in Bcnf if it satisfies two conditions. The first condition is that it should meet all the requirements of third normal form. The second condition is that for each functional dependency, x determines y holds in relation R, then x must be a superkey of R and y must be a subset of x. Now, let us see an example for Bcnf. Consider student table. In this table, roll number and teacher ID are composite primary keys that determine course ID and exam date. Hence, we can say that the relation is in third normal form since there is no transitive dependency. However, in this table, one more dependency exists. That is, from course ID, we can determine teacher ID. Even though course ID is a non-key attribute, it can still determine teacher ID. Therefore, we can say that the relation is not in Bcnf. So how can we comply this table with Bcnf? To do this, we can separate roll number, course ID, and exam date in the first table as student exam table, and course ID and teacher ID in the second table as course teacher table. In student_exam table, we have roll number and course ID as the primary key to determine the exam date, whereas in course teacher table, we have course ID as a primary key to determine teacher ID. Now we can say that the relation is in Bcnf. There are other instances where an attribute in a relation is dependent on multiple values of the same relation. So, to overcome multi-valued dependency, further normalization to 4NF and 5NF are required. So what do you mean by multi-valued dependency? Multi-valued dependencies occur when the presence of one or more rows in a table implies the presence of one or more other rows in that same table. Hence, we can use the fourth normal form to remove multi-valued dependencies from the relation. Fifth normal form exists when the relations in fourth normal form still have a problem. The relation is said to be in fifth normal form if it satisfies two conditions. The first condition is that the relation must be in fourth normal form. And the second condition is if we decompose the table further to eliminate redundancy and anomaly, the joining of decomposed tables neither lose its records nor create new records. If these two conditions are satisfied, then we can say the relation is in fifth normal form. Now let us have a quick recap of this video. Normalization is a method of organizing the data in a database. It uses a set of procedure to remove redundancy and anomaly from a relation. Database normalization are divided into 6 normal forms. First normal form, second normal form, third normal form, Boyce-Codd normal form, fourth normal form, and fifth normal form. Thank you for watching this video.